Hello Math 8 students, this is our end of year review. Today we're going to be covering a couple of topics. One of them is properties of exponents. So you're going to begin with this quick pull, simplify this, make sure you enter it into your calculators. We'll talk about it once you've entered it. Okay, and now that we have it entered, we are going to simplify it by hand, seeing what it looks like. As I have said, when in doubt, expand it out. So when I'm expanding this out to see what this is going to simplify to be, I can see I have 2, and then x raised to the second power. X raised to the second power means x times x. That's multiplied by 3, which is multiplied by x to the 5th power. That's x times x times x times x times x. When you expand it out, you can see all we have is simply 2 times 3 using the commutative property, multiplied by 2 x's, multiplied by 5 more x's, and mathematicians are lazy, so instead of drawing out all of those x's, we decide to shorten it. This is 1, 2, 3, 4, 5, 6, 7 x's being multiplied together, so x to the 7th power. We just multiply 2 times 3, and 2 times 3 simplifies to 6. Ultimately, our goal is we should know those exponent properties, but we know those exponent properties because we've expanded these out enough that we realize we want to be lazy and we don't want to have to continue expanding them, so we start looking for properties, some patterns, and those patterns are what really become the properties of exponents. So today we're going to start this review, which does include applying the properties of exponents, practice, but it also includes scientific notation. My goal is to get through these 2 sections today. We also have functions review, and we have some Pythagorean theorem review. So those are the things that are going to be covered on our final test on Friday, and these are the things that we need to be practicing and reviewing in class. So, getting started, applying the properties of exponents practice. One of the things that is important to note on all of these problems is what is the exponent attached to? I believe that students make mistakes on this one because they are thinking that the 2, this power of 2, is attached to this 2, and it is not. If it were, then it would have to be in parentheses saying this power goes to both of those pieces. But since there are no parentheses, that means that this power, this exponent, is only attached to the thing it's the closest to, which is the x. Same thing here. The 3 did not have the exponent. The exponent is only attached to that 5, so only the x is being raised to the 5th power. So, with that in mind, I want you to do your best. Give these ones a try. I think we can go all the way to the end, 1 through 14. Do as many as you can. We're going to pause the recording as students work on them, and we'll return after a 3-minute pause break. Ready, set, go. All right, let's see what you were able to get done, and let's review some of these properties now. Again, when in doubt, expand it out. 3 times k to the 4th multiplied by k to the 2nd. I'm going to expand this out. K to the 4th is k times k times k times k. Times k to the 2nd is multiplied by k and k again. And don't forget that is still multiplied by 3. Once again, as a reminder, the 3 does not have the exponent, only the k does. So when I see this, I start realizing, wait a second, if 4 k's are multiplied together with 2 other k's, that means altogether I'm going to have 6 k's multiplied together, or k to the 6th power. So again, the whole point of these properties is when I realize the patterns associated with simplifying, I can make up those rules, and those are the properties. How did this 4 and this 2 become a 6? How are we combining them? Luis? Yeah, ultimately, what do? I add them all up together. So 4 k's multiplied by 2 more k's means I have a total of 6 k's 4, and then 2 more is 6. All I'm doing here is adding those exponents. That might help you for some of the other ones. Let's see what you did for number 2. Again, when in doubt, expand it out. So this looks very similar to the one that we had for our warm-up. P times P times P multiplied by the 2. That's multiplied by this 3, which we then are multiplying all of that by P to the 4th power, so P multiplied by itself 4 times. And again, using the commutative property, that means I realize I can just multiply the 2 times the 3. There's no reason to keep them separate. And 2 times 3 is 6. But then when I continue to look, I realize I have 3 p's that are here being multiplied by these 4 p's over here. And altogether, that's 7 p's multiplied together, or p to the power of 7. Again, what am I doing with those exponents? 3 here, 4 more here, for a grand total of 7, because I'm simply adding those exponents. And don't get too used to adding exponents, because on number 3, it is not going to be n to the 7th power. When you actually expand it out, we have n to the 2nd multiplied by n to the 2nd times n to the 2nd times n to the 2nd times n to the 2nd power. Again, because I have n to the 2nd, which is raised to the 5th power. So there's 5 n to the 2nds multiplied together. But then when I really break it down and realize, wait, there's 2 of them here, and 2 more here, 2 here, and 2 here, and 2 here, 2, 4, 6, 8, 10, that means altogether, even though I didn't draw them all out, I know that there are 10 n's multiplied together, or n to the 10th power. So what's happening with those exponents? How is 2 and 5, how is that turning into a 10? What are we doing with those exponents? Emily? Yeah, it's 2 times 5. 2 groups, or I'm saying that backwards, 5 groups of 2, right? So we multiply n to the 10th power. That will probably help you for number 4. Go ahead and try that now if you haven't done so already. What do you have when you, if we were to expand it all out, but I'm hoping that we start realizing these patterns soon. If I were to expand this all out, how many v's would I draw all multiplied out together? Joshua? Good. So this is going to be v to the power of 12. Then we start seeing something interesting on number 5. We talked about understanding what the exponent is attached to. So talk at your tables on number 5. What is the exponent of 3 attached to? What is the exponent of 5 attached to? And what is that going to look like? Talk at your tables. Ready, set, go. Okay, what is the exponent of 3 attached to? Gabe? No. Yeah, the 3 is only attached to the m. So m to the 3rd power would be m multiplied by itself. There's 3 of them there. But what is the 5, the exponent of 5, what is that attached to? Luis? It's attached to everything. So that means when I have this here, this 4 multiplied by m times m times m, I actually have 5 of those. So if I were to expand this all the way out, how many times would I show that we're multiplying by 4? 5 times. Yeah, I would make this 4, and then another one, and then another one, and then another one, and then another one, because we would have those 5 different groups. I will expand that out just so that you can see. But this is how I'm expanding it out. I'm totally taking advantage of technology. There's 1, 2, 3, 4, and 5. With that being expanded all the way out, now you can see it is 4 to the power of 5. Notice what I said. 4 to the power of 5, not 4 times 5. 4 to the power of 5. And m, 3, 6, 9, 12, and 15, that's m to the power of 15. So again, understand how those properties apply. One thing that's worth noting, I like it written as 4 to the 5th power. When you take the test, it may keep it as 4 to the 5th power. It might ask you to expand it out. So what is 4 to the 5th power? That's when we would take advantage of our calculator and use that. 4 to the 5th power is 1024. Yeah. Remember how we said it's not multiplication. It's not 4 times 5. It's 4 to the power of 5. So this would simplify to be 1024 m to the 15th. All right, now is a really good time to pause the recording again. I want you to really think hard about numbers 6 and 7. 6 and 7 are very interesting, and they do take some recall or some reviewing of notes. So take a second and discuss 6 and 7 with your tables. Ready, set, go. Okay, now that students have had a chance to check in at their tables, number 6, d to the power of -4. What does that mean? Joshua? Exactly. We need to remember what negative exponents mean, and we talked previously that negative exponents is division. And to clarify, for anybody who has been confused about this, we first introduced this with something like d times d times d is equal to d to the power of 3, right? D times d then is equal to d to the power of 2. And you can see we're slowly shrinking down the number of d's that we have. This is d to the power of 1. Something needs to go here. What would d to the 0 power be? That's our next one that we're going to be discussing. But then I also want us to understand that 3, 2, 1, 0, it makes sense that this would become -1 and -2 if I'm continuing to follow this pattern. But I want to understand what's happening here. Here I have d times d times d, 1 fewer d. How could I get 1 fewer d in the previous or in the next row? Well, if I just divide 1 out. So in a sense, it's like I'm dividing 1 out every time I go down. So what happens if I have just 1d and I divide it out? What am I going to be left with? Not nothing. What's any number divided by itself? Yeah, it's 1. That gets us very nicely to d to the power of 0 would be 1. But what if I were to divide by d again? Because that's what I'm doing each time I go down, right? We're dividing by d. 1 divided by d is just that. It is 1 divided by d. And so we can see that d to the power of -1 means I've actually divided by d 1 time. So that helps us understand both number 6, why those negative exponents mean we're dividing, and number 7, p to the 0 power is what? I asked you to talk at your tables now. I should see responses. D to the, or p to the power of 0, Cambria, is 1. We saw this in our lesson by something like x times x times x divided by x times x times x. We could write this as x to the 3rd divided by x to the 3rd, and I realized, hey, wait a second, here I would just subtract these exponents. And 3 minus 3 is 0. But I also realized going the other way that all of these things divide out to be 1, and that's how I come to that conclusion that anything raised to the 0 power is equal to 1. All right, and now we have reviewed those negative exponents, so now it's time to put those into play. This is really, truly no different than problem number 1. It's just now I've got these negative exponents. So what do those negative exponents mean? How am I going to handle them? Quick discussion at your table. I am not going to pause the recording. Discuss at your tables. What am I going to do for number 8? Okay, what are we going to do for number 8? Good. So you're right, we would normally add these exponents just like I did up here. 4 plus 2 was 6. Here, 3 plus 4 is 7. So I'm going to add these exponents, but negative 9 plus 6 simplifies to negative 3. And we can't have those negative exponents. I believe it said that in the directions. Yeah, your answer should contain only positive exponents. So when I have simplified, all right, I want to show multiple ways that we can look at number 9. On number 9, when I see just this part right here, y to the negative 5, I realize that that can be written as 1 divided by y to the power of 5. And that is multiplied by 2, y to the 5th. But I realize that anything can be written as a fraction by putting it over 1. So that's what I'm going to do. 2 times y to the 5th over 1. Now, do you see how this really can just be combined into just one fraction? What's going to happen when I have 5 y's on the top and 5 y's on the bottom? They all divide out, right? So what is it that I'm left with? Just 2. 2 times 1, which is 2. 2 divided by 1, which is 2. How else could I have done this? Another way that I could have done this is by realizing, hey, wait a second, I can add these exponents. Negative 5 plus 5 is going to be y to the power of 0. Don't forget, we're still multiplying that by 2. But what's anything to the power of 0? Just 1. So this simplifies to 2 times 1, or simply 2. And that's why I love these properties of exponents, because you can simplify it in any way that your brain makes it work, and you'll still get the same answer. So you have lots of different options. Number 10. I have 4x to the 4th divided by 2x to the 2nd, and I realize that 4 divided by 2, that's going to simplify to 2. And if I have 4 x's on the top divided by 4 x's on the bottom, that means 2 of them will divide out, so I have x to the 2nd. I'll show you what that looks like if I expand it out. 4x times x times x times x divided by 2x times x. Again, 2 of them are dividing out, leaving me with just 2 left, x to the power of 2. And 4 divided by 2 simplifies to 2. So when you recognize those properties of exponents and know how to use them, you can make your life a lot faster and easier when you're simplifying these. If not, you can always expand it out. Number 11, what we want to be careful of with number 11 is what is the exponent attached to. So 2x cubed, that means the exponent is attached to the x. Not the 2, just the x. But here, the exponent is attached to the parentheses, which means it's 2x raised to the 4th power, so we're multiplying that 2x by itself 4 times. When I expand it out, I can start seeing, hey, I've got 1, 2 here, another here, 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 and here. So that's 2 multiplied by itself 5 times, so 2 to the 5th power. Let's start counting up the x's. I have 3 x's here, 4th, 5th, 6th, and 7th x, so that's x to the 7th power. But again, 2 to the 5th power can be simplified in our calculators. Anybody can beat me to that? No, it is not 2 times 5. Stop making that mistake. 2 to the power of 5 means 2 is multiplied by itself 5 times. Gabe, what do you got? I don't think so. Yeah, do 2 to the 5th power. Trace? 32 sounds right. Let's talk for just a second since we keep on making that mistake. 2 to the 5th power means 2 times 2 times 2 times 2 times 2. 2 multiplied by itself 5 times. That is very different than 2 just multiplied by 5. We need to make sure that we understand what powers are and how to use them. And you're going to have your calculator, so please use those calculators. Okay, 12, same thing. What is the exponent attached to? Let's really take the time to figure that out. Here, a to the 4th, that's a multiplied by itself 4 times. And then we have parentheses, a to the 2nd power, which is multiplied by itself 5 times. Even if you don't want to expand it out all the way, just taking the time to do this really helps us out. I've got 4 here, 2, 4, 6, 8, 10 here. So 10 and 4 mean I have a to the 14th power. Before I even attempt to do this one, I'm actually going to try and simplify it. Before I see that it's raised to the 5th power, do you see how we have 2x divided by x times x times x? Simplify that inside first. What do we have? Those are dividing out. That means raised to the 5th power, I have 2 divided by x squared, which is then raised to the 5th power. And now we can expand that out. I'm really starting to feel lazy because I'm realizing, wait a second, that just means I'm going to have 2 multiplied by itself 5 times. And on the bottom, I'm going to have x to the 2nd multiplied by itself 5 times. So how many x's will there be? X squared multiplied by itself 5 times, x to the power of 10. And last, the best of all the game, this is going to be p to the 3rd. If I expand this out, p to the 4th multiplied by itself 5 times. P to the 4th times 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 p to the 4th. 4, 8, 12, 16, 20. But 3 p's multiplied together on the top divided by 20 p's multiplied together on the bottom mean I'm actually going to have 3 of them dividing out, p to the power of 17 in the denominator. What questions do you have? Joshua, you had your hand raised. Did you find a mistake or something? No? Okay. All right, let's move on to the next topic. The next topic is on scientific notation. We will probably not finish all of this today, and knowing that I am not going to finish all of this today, I'm actually going to skip it. We'll start fresh on scientific notation. Let's skip ahead to functions. So that would be on the back side. Functions. We need to look at each of these relations. Some of us are giving to us in a mapping situation. Some are given to us as graphs. Are these functions? So talk at your tables first. What do you remember about functions? I'm going to pause the recording as students talk and review functions. Ready, set, go. What is a function? How can I look at these and decide if it's a function? Gabe? Yeah, it's not one-to-one ratio, but one-to-one relationship, exactly. So keeping that in mind, functions are one-to-one. Now we need to decide what that means by looking at some examples. Part A, is this a one-to-one relationship? It looks like it though. Raul is a student, Raul orders pasta. Tony's a student, Tony orders salad. How come it's not one-to-one? Luis? Close. Yeah, so me just looking at the first couple isn't going to provide me with enough information. I have to look all the way down at the bottom and I see that Jamal is ordering both steak and pizza. It was one-to-one until we got to Jamal. So is this a function? No. Jamal orders 2 items. One student orders 2 different things. Jamal's hungry. Jamal's a growing teenager. Part B, is this one-to-one? Why is it one-to-one? I feel like it's not because I can see 2 people are going to red. So how can you say it's one-to-one? Bella? Good. Yeah, it doesn't matter how many people are choosing red. It matters, is Sam choosing only one color? And Sam is choosing only one. Joe is choosing only one. Luis is choosing only one. And Maya is choosing only one. So yes, this is a function. It is one-to-one. Okay. Let's finish these up. Part C. Give a second to think about it on your own. In fact, we're going to pause the recording as you think about C, D, E, and F. Now that we've reviewed what a function is, C, D, E, and F, give them a try on your own. All right, C, there's no context. It just has input and output. Is this a function? Yeah, it is a function. Each input 3 goes to only one output 7. 5 only goes to 5, 7 only goes to 3, and so on. So yes, this is a function. It is still one-to-one. And I really like D. Is this a function? We don't have a map anymore to show us if it's one-to-one or not. So how can I look at a graph and tell if it's one-to-one? Dylan. Good job remembering that vertical line test. The vertical line tells us if it's one-to-one or not. As I place a vertical line, I can use the pencil, a ruler. I actually have a line tool. I'm just going to run it across the relationship, and I can see here it only crosses one time. But what about the input of, let's just go here. What about the input of 2? When the x value is 2, how many different y values are there? There's 2 of them. And so this fails the vertical line test. If I want it to be even more clear, I can say x value of, and there's lots of them that do, but let's just pick one. X value of 2 has 2 different y values. That's what that vertical line tells us. That vertical line test tells us. Okay, E. Is it a function? Is the type of country, is the type of music that you like, does that determine what your name is? No, not even close. So, country music could be liked by Jace, it could be liked by Jeb. So this one is not a function. It's not one-to-one, and I can specifically say country music has 2 outputs. All right, what about a pianist's overall score in a music competition? They scored a 10, that means that they rated superior. They scored an 8, that means they rated excellent. A 7 is good, a 6 is good, and a 5 is fair. Okay. What do you think? Is this a function, yes or no? Yeah? Why is it a function? Grant. Yeah, it is one-to-one. Even though 7 goes to good and 6 goes to good, 7 only goes to good. 7 doesn't go to good and excellent. So each input still goes to only one output. All right, and that's all that we're going to cover in this video. What we're going to cover tomorrow to help us review is we're going to look at scientific notation, and we're going to look at the Pythagorean theorem, and that's what we'll look at tomorrow. Thanks for watching. We'll see you next time.